Hi guys, and welcome to this episode of Physics Weekly. Today we're going to talk about what is probably one of the biggest and most heard of topics in physics. What we're going to talk about is Newton's laws of motion. Now let's not waste any time and get right into it. The first law states that an object will remain at rest or will continue travelling at a constant velocity unless acted upon by an external force. Now the first part of this makes sense. An object won't move unless you give it a push. But the second part is a bit more confusing. How can something keep moving when there's nothing there to push or pull it and to make sure it keeps moving? Well, think of it like this. If we ignore friction and air resistance, when you place a force on an object, it will start to move and speed up. Now, because there is no resistive forces, that means there's nothing there to slow it down, right? So if you were to remove the force pushing the object, there'd be nothing there to speed it up. And because there's no resistive forces, there's nothing there to slow it down, and thus the object continues to travel at constant velocity. Moving swiftly onto the second law. The second law states that the net force in an object is directly proportional to the rate of change in momentum, although this is more commonly written as F equals ma. But these are both the same thing, and here is the proof. Now, the change in momentum is equal to mv minus mu, and because the mass is constant, this can be factorized out, leaving us with v minus u over t. Now, you may notice that that is equal to the acceleration, so if you sub in a, then that leaves you with the equation F equals ma. Now, this law is very useful because it allows us to work out how much force we need to apply to an object of a certain mass to get the desired acceleration. It also means we can think about an object's inertial mass, which is a measure of an object's resistance to a change in motion. You can do this by applying the same force to different masses and comparing the acceleration, and obviously you would find that the object of greater mass would have a smaller acceleration. Finally, onto the third law. The third law states that when object A exerts a force on object B will exert an equal and opposite force on object A. Or put simply, every force has an equal and opposite reaction force. Now, how does this one work? Well, let's use the example of someone pushing a ball. Now, as we know, when there is a net force acting on an object, it will accelerate forward. Now, if you were to push a ball, the chances are it's not going to move. This must mean that the net force is equal to zero. And where is this reaction force coming from? The answer to that is the wall. When you push on the wall will push back on you. And that is the reason why the wall will not move when you push it. Another example of where you can see this is if we had two people on different skateboards of different mass. When one pushes the other, they will both move back, and due to Newton's third law, they will receive the same force in opposite directions. But due to the difference in mass, they will move away from each other at different accelerations proportional to their mass. The third law can be seen in other places such as swimming and when birds fly. When you swim, you push the water back, which pushes you forward, and when the bird flaps its wings, it pushes the air down, which pushes the bird up.